ladies, page 56. Now, dot plot is just a number line, and we use it for your quantitative data. And each data entry is a point above that line. It's kind of almost like the stem and leaf, but where the stem and leaf had groupings, this has each individual point. So the stem and leaf was, I like it better because while it showed your groups, it kind of strung out your leaf so you can see your individual points. This one's a little bit harder to follow. You actually have to make a number line with this and put each point on this. This really makes a nice a visual to this, like a three-dimensional thing. And kind of see if you have use for it. Sometimes it's nice just to plot your data to see where it is in relationship to everything else. Because if you kind of look at a whole bunch of numbers mixed together, you really don't understand where they're gathered, where the groupings are. So a dot plot is helpful. A dot plot says this. Take a number line, find your minimum, find your maximum. So with all this, what's your minimum point? 78. What's your maximum point? 159? Okay. We used this data before. So now, your number line has to be able to go from 78 to 159, or 75 to 160. And every number has to be accounted for. If you take a look in your book, they already plotted this out. So I'm not going to plot the whole thing out, but I want you to see how we build this. So they account for every one, 76, 77, 78, 79, 80. They account for each one. I want it quiet, guys. If you need to talk, you need to go somewhere else. Because the first one you need is 78. Well, because you want to make your number line like kind of uniform. Yeah, I mean you can start at 78 if you like, but then you're going to have to start with little tick marks. So you just kind of go all the way up here. It's a pain. You have to account for every single number. Okay, I didn't have to go that far. Okay, you have to account for every single number. And this is how you do your dot plot. You start with your numbers and you say 155. You put a dot. Then you go to 159. You put a dot. You keep the first ones on the same row. The horizontal, they have to be the same. Unfortunately, my number line is a little crooked. 144. You put a dot. You keep doing this. 129. You put a dot. 105. 145. For each one of these, 126. You keep going with your dots. 116. 130. 114. 122. Did we have a 122 or not? 112. Okay, now, here's two 112s. The next one goes right above it. See how it goes? Now, everybody else on that second row has to align with that one. You have to be able to see it. Take a look in your book and take a look at what they come up with. Yeah. The nice part about this is you end up seeing a lot of groupings. Here's one all the way by itself, but you see groupings. You can see the 126 is going to be your highest one. That's going to be your highest one. You can tell where your endpoints are. You can tell where your groups are. Most of your data is grouped right in here. That's where most of your data is grouped. This guy out here, anybody know what that's called? That doesn't conform to the rest of your data? What's it called? Outlier. Good. This is called an outlier. Good. It lies outside of your data. Everybody else kind of stays in that same area, and this guy kind of does different ones. Now, when you're collecting your data and you find an outlier that is very extreme from the rest of your data, you want to investigate it to make sure, is it a valid entry or is that the norm? You could have those. So a dot plot gives you each individual one. It almost built a histogram with one number, if you took a look at it. It's like a visual histogram for every single number. There's no intervals. I could tell how many 126s I have, how many 130s I have. You can see that on your stem and leaf as well. But your stem and leaf is still grouped by an interval. This one, a one-on-one, all the way through. So you kind of get how a dot plot is done. The most important part is this piece right here, your number line. You have to have an evenly spaced number line. And all your dots, when you do this, they have to come up the same way in the next row. Whatever they come up as, they have to be equally spaced apart. Know if these are the entries. You have to be able to tell where they are. Okay? They give us a dot plot to do. Do you guys want to try it, or do you think you're okay with doing a dot plot? Okay? Let's just lay out the number line for this. How's that? We'll just lay out the number line, and we'll just put like 2 or 3 dots in it just so you get the gist of it. Yep, the gist of it. So, what's your lowest number on your ages? This one was nice to remember because these went in order.
26.
What's your highest number? So,
25 to 90 then.
25 to 90 sounds good to me. They account for every one, so don't forget. So I'm going to just go by 5s, but they go by 5s in every one. Okay, again, you want to give this a title. This is the ages of your most powerful women. Guys, I need the conversations to stop. Okay. Get your number line and just plot your points. Again, this account, every data is represented by a point on your graph. Every piece. So it's kind of like making a visual histogram for each point. So 26. Then 31, then 35, then 37, then 43. Let's hit a double one and then we'll stop. And there's another 43. Place it right above it. See it? And another 43. Okay. So you see how this works? You should be able to build this. And this is kind of nice if we did this one out. This would be kind of nice because you can actually see who's got the most, which data pieces represented the most, where's their outliers. You really don't have too many, you don't really have an outlier here. They're kind of like, even though they're grouped more in the middles and the 50s, they're still kind of evenly spaced apart. What's nice is you can almost see, is it an even looking curve? Is it kind of skewed a little bit? Do you want to do them out, or are you okay with this? Okay. Do you want me to all the dots? No. The dot plot just takes a little time. It's tedious. You have to follow every point. But it gives you a nice visual representation of this. Now, they have, on the bottom of 57, they have a dot plot that they did on a mini tab. Sometimes you're going to get software, mostly in college, you will use whatever software the college has. We don't have any to use here because we don't get labs. Well, in high school you usually don't. You can usually use your graphic calculators, but in college they usually have specified labs. So you go to your statistics lab for the afternoon, or sometimes you have an extra period even. And some colleges do, some don't. But they have certain software. Minitab is one. There's a couple of them. They probably list them somewhere. Minitab's not that popular, but the other ones are. And you go in and you'll use their data. It prints pretty much, you enter your data, and sometimes they even tell you where to find it on a disk, or they put it out on a cloud somewhere. You get your data up there. So there's most of the times the computers will do all your calculating. So this is your dot plot. It's a little tedious, but it's kind of a nice visual on each one. Your pie chart is your circle. This one's very, very popular. Your pie chart has percentages. You can set them up with angles as you did in geometry, but mostly in the business world, percentages. This is what you display. This is your last thing that you are showing somebody. This took all your data and put it together. Most business people want to see percentages. What percent of my company is doing this? What percent should I pay attention to that? They want to see percentages. Now, when you do your pie chart, you're going to take all your possible pieces and add them up. You need a total. You're going to take the total. This is on page 58. You're going to take the total of this. You're going to put it in your calculator. You're going to add them all up. And it totals 3,553. Now, this is your relative frequency, your part over whole. So 942 over 3553. This is going to give you a decimal. Once you get your decimal, this is your relative frequency. Before you flip this to a fraction, if you want an angle, how many degrees in a circle? 360. So if you multiply that decimal by 360, it tells you what angle that sector took up. So when you multiply that, this will give you 95 degrees. To get the percent, you just move your decimal place 2 places to the right or multiply it by 100. This is 26.5%. Now, you can round this to 27%. Depends how exact you want to be. Before you round it, before you flip it to a percent, multiply it by 360 to get your angle. So the second one, part over whole. You're going to divide that first, part over whole. Go 3 decimals. 3 decimals because when you move that percent, you don't want to lose that rounding. So 3 decimals will give you 0.483. Bless you. Multiply this by 360 and get your angle. In this case, 174. Some of you like to look at angles when you look at a circle. Some of you like to go by percents. Move the decimal, 48.3% or 48%. 731 over 3553. Divide it out, 3 decimals. Multiply it by 360. This will give you your angle. These are where all these numbers come from. Everybody seeing this? Part over whole, that's all it is. Give me 3 decimals on this. You don't want to lose your percent. Well, I can give you the percent for that. Well, because I'm going to show you in 1 second, it's easier to do the percents. Most of the time you do the percents, not the angles. I do percents, not angles. But you can do it either way you like. You need to put the percents on it because that's what they need to see. Yes?
How do you get the 3,500?
You add up all the pieces. Totally. Totally. And so this side is 4.6%, or we can round this to 5%. Now, here's your percentages. Watch. When you make a circle, and you divide this into quadrants, each quarter is 25%. This is how you work your percents. I've got a 27%, I've got a 48%, a 21%, and a 5%. And these better total up to 100. If they don't total up to 100, then something's wrong. Sometimes they don't exactly total to 100 because you have rounding in here, but they'll be real close. But sometimes you want to leave it with a decimal. The easiest way to do this is work the 25s. So 27 is a little bit over 25. Start like this, a little bit over 25. So this piece right here is your 27%. You have to put your percent on here. You have to put your title in here. This is 25. If we use two of them, how much is left? We used 2%. If this is 25,
Well,
how much is left in this quadrant right here? 23. Okay, now I'll go for my 21. From here to here, 21%. How much will be left over? 2. I've got a 23. How much will be left over? 2. Just keep track of it. So 21% was your master's. 48%. 48% is darn close to 50, isn't it? All the way from here to here. This is my bachelor's. 48%. And this little guy left is my 5%. And he is doctorate. Okay? So that's how you get your pie chart. Now, no one's going to measure this exactly. If I want to start with my 5%, start with your 5%. But the thing you want to do is make sure that this 48% is close to that half. You don't want to have this as your 27%, this as your 48%. Another way to do this is angles. If you use your angles and you set up your circle, but you're still putting it in quadrants. Every quadrant is 90 degrees. So this is slightly more, 95. See it? Same way we did the first one. This guy's 174. From here, almost down to here, is 174. And then you can kind of figure what one is 5%, which one is 20%. No one's going to measure. It doesn't have to be exact, and it doesn't have to be the same as your neighbor's circle because it depends where you start. But you want to make it in that ballpark. Okay? I personally like the percents. You do it the same way with angles. If angles are easier for you to work, then work angles. Otherwise, do your percent. I find them to be. So when you total this column, what is this total? 1940. That's it? Okay, part over whole. 455 over 1940. So what does that come out to be? 3 decimals. Okay, if we multiply it by 360, we'll get the angle, which is... So we'll make it 35? 85. Then 85 degrees? Is that right?
Yeah.
Okay. The next one, 1051 over 1940. What's your 3 decimals?
0.542.
And so this will give 54%. We can keep this one. Times 360 is what?
195.
Yep, you gotta round it. This one, 330 over 1940 is what?
0.170.
Okay, times 360 is what?
16.
And we'll move this to be 17%. And 104 over 1940 gives us what?
0.054.
Okay, times 360 is what? Is what degrees?
19.
19 degrees, thank you. And 5.4%, so this is about, we're going to say 6%. 5.4, 5%. 5%. The percent, just multiply this 3-digit number by 100, or just move it 2 positions to the right. But you don't want to multiply it by 100 until you multiply by your angle first. Then you got to move your decimal back. Now, you want to make sure that these add up to approximately 100. We messed around with your rounding. So now we're going to make your circle. And we're going to title it, these are your earned degrees, 1990. Again, start with 25%. It doesn't matter where your pieces go. I like the 24, so I'm going to put mine right here, just a little bit short, 24%, and I'm going to put the title, Associate. Whatever you do, don't put 455 in here because nobody understands 455, what that means. Okay, so we did this guy. 54%, well, this is 50, a little bit more. So from here to here, this is my bachelor's at 54%. Okay, now estimate. You got a 5 and a 17. Who has to be bigger, the 17 or the 5? 17. Isn't 17 like 3 times the size of the 5? So eyeball it. If you could divide these into 4s, 3 of them would have to be close to your 17. This is close enough. This is your master's, and your doctorate is in here at 5%. Okay? As long as this makes sense. You don't want to see 54% being less than a half. You don't want to see 24% being more than a quarter of your circle. You want it to be in the ballpark. Is anybody going to measure that I've got 5% in my 17 that they measured exactly? No, they're just going to look in the ballpark. A lot of times you'll see them displayed in mixed colors. If you look at your book on page 58, they're displayed with colors. They make them pop out a little bit better. They pop a little bit better. You good with the circle graph? These are popular. These are really popular. If you like to use angles, by all means, use your angles to help set your pieces up. Half of your circle is how many degrees? 180. And what is a quarter of your circle? 90. So if that is where you see it better, use your degrees.
Or calculation of 50%.
Yeah. I happen to like percent, but it works in the same principle as when you're finding your angle. But you have to put your percents anyway. Anybody have a question with this? Everybody can do this?
Doesn't matter how you
No. If you put your 5% here, your 17% here, 17 and 5 is still a little bit less than 25, right? So I'm a little bit less. If this was my 17 and this is my 5, and my 54 goes here, absolutely fine. Absolutely fine. I just don't want to see like your 54 being here, part of your graph. You know, you need to make sure that's more than half of your graph. And then this would be your 24%. So it kind of still fits in to play. They have to be within the ballpark. We don't use a protractor, we don't measure angles. We just make sure it's a reasonable look. Okay. Now, the next graph we're going to talk about today is your Pareto chart. These you haven't seen. A Pareto chart, if you take a look at page 59, is another way to help you graph your qualitative data, your categories, your nominal parts. Like I want to know, in this case, where my biggest shoplifting, where my biggest losses of inventory were. So maybe as a manager, I want to know, show me the highest. Where am I losing my most? Down to my least. Because what are the things I want to focus on? The bigger parts of it, not the smaller parts of it. So while a circle graph is nice for that also, a Pareto kind of sets it so that you can look highest to lowest. They use bars. We use bars. We have gaps between the bars because this is qualitative data. So we put gaps between your bars, and you can use your frequency or your relative. Most of the time, it's your frequency. And we use your vertical axis to be your frequency. Your horizontal axis is where your categories go, like this. Now, what's nice about this is, again, it gives it to you at a glance. So if you take a look at their example, in a recent year, the retail industry lost $34.5 billion in inventory shrinkage. And inventory shrinkage is the loss of inventory through breakage, pilferage, shoplifting, and so on. Here's your major causes of what causes your inventory shrinkage. Administrative error was accountable for $4.2 billion. Employee theft, $15.1 billion. Shoplifting, $12.3 billion. unknown, this could be a number of things. Things mismarked, mislabeled, misread, whatever. Vendor fraud, 1.7 billion. You want to make a Pareto chart which shows them from the highest to the lowest, because someone looking at this wants to hit the highest cost first. So your graph is going to be again in quadrant 1. On your x-axis are all these categories. Just your categories. These are nominal entries, qualitative entries. So they go here, from highest to lowest. So which one has the highest out of all these? Employee theft. So here's my employee theft. Then what? Shoplifting. Next is shoplifting. Then what?
Administrative error.
Administrative error. Then vendor fraud. And finally, your unknown. Usually everybody has some kind of a miscellaneous or an unknown. There's no reason to break your bar because there's no quantitative data on that. Your quantitative data is here. This is the frequency. This is how much I have lost. The amount lost in billions of dollars. So we want to go from 0 to the highest, which is 15. So you just make your graph to go up to 15. And you call this is your inventory shrinkage. And you make your bars. Employee theft, 15.5. That was your big one. See that one stand out? Shoplifting, make a space. 12, guys, don't pack up yet. 12.3. Administrative error, 4.2. Which one are you going to address so far? The employee theft. Okay, you keep on going. 1.7, vendor fraud. 1 to 1, and then this guy, 1.1. Okay, so you get a chance to see this highest to lowest. And they kind of stand out that way. Now, if you're, see the Better Business Bureau, if I'm the Better Business Bureau doing this, I might want to go for which part? I'm the Better Business Bureau. Well, which one would I want to go to? What category? Vendor, because I could attack the vendors, right? Could I attack my employees if I'm Better Business Bureau? Nope. Shoplifting? I might want to go for shoplifting. Employee theft? Administrative? I want to go for the vendor if I'm Better Business. But for a person who's looking at this, they want to hit the highest one. I guess we're packing it up. 1 minute.